Today's lesson is going to focus on 6.7, which is solving quadratics by completing the square. There are two parts of it. We're going to focus on the first part today, where a is equal to 1. The next part will be where a is greater than 1. So on page 42, let's go ahead and take these notes. Go ahead and pause the video. Now that you've taken these notes, you'll see that it gets a little confusing. You're like, whoa, 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 it's another formula I have to remember? The main one you have to remember is what's written in green. That c, instead of writing like we do in standard form, instead of writing c for the constant, we're going to actually look at it as a b over 2 squared. So let's use problem number 1 to help us understand this a little bit better. Your first instinct is usually like, oh wait, it's not set to 0. Don't make it set to 0. Leave it be. This is helpful of when maybe one part is a perfect square, but it's like, hold on, we have things to do here, right? What I'm going to notice is that this is factorable. I can separate it, so it's x plus 2 squared, right? That's like x plus 2 times x plus 2. We can go ahead and factor that. Then I'm left with a square. This is exactly like we did before. We're going to take the square roots. So we get a positive negative 5. On the other side, we're left with x plus 2. We're going to separate it so that we have our two equations, where it's 5 equals x plus 2 and negative 5 equals x plus 2. We're then going to solve. So x equals 3. And here it is a negative 7. So we have our answer of a negative 7 comma 3. Now, these are perfect square trinomials. I'm telling you that they're already set up as perfect square trinomials, so that we can factor them and then use square roots to be able to solve them. That's not always going to be the case. You can use this page to practice that with factoring and combining it with the method of square roots, but that's not always going to be the case, right? Sometimes you're going to have to create a perfect square. I'm going to show you how to do that. All right, so go ahead and flip to the next page and take the next set of notes. Also copy down the example just so you can visually see where each part comes from. You can pause the video. Now that you've taken the notes, what you can see is I've written that if we don't have a perfect square trinomial, like I can't factor it. Okay, well then I can create one by completing the square. What this allows me to do is balance the equation. It's like, hey, I'm going to add a little to this side, I'm going to add a little to this side, and now I'll be able to factor it perfectly. So, number 1. I notice, well, nothing multiplies to 27 and then gives me a negative 12. Right? We ran into that situation when factoring. Okay, so this is not going to work to immediately factor it. So what I'm going to do is bring the 27 to the other side, right? I'm going to bring my c. So I have a negative 27 equals x squared minus 12x. Right? We're rewriting it so b is on the other side. C is on the other side. Now we're going to use b over 2 squared, just like your notes say, right? We're going to use this formula, which in case b is a negative 12. So I have negative 12 over 2 squared, which gives me negative 6 squared, which gives me a 36. So this 36 is what I'm adding to both sides. That's what it's going to help me create it. So over here, I get a 9. And on the other side, I can rewrite this, or I can actually go ahead and factor this. You actually don't have to think about how to factor it, because what's in parentheses here tells you how to factor it. It actually tells you it's going to be x minus 6 squared. It sets it up for you, so you don't have to think about, oh, how do I factor this? Actually, the b over 2 tells you how to factor it because it sets up a perfect square trinomial, right? 6 times 6 gives me 36, and in this case, negative 6 times negative 6 gives me 36, and negative 6 plus negative 6 gives me a negative 12. Well, now I can just square root it. I get the positive negative 3, and the other side is x minus 6. So when I split it up into 2, I get x minus 6 equals 3. The other side I get x minus 6 equals negative 3. So over here, x equals 9, and over here, it's 3. So my final answer are 3 and 9. Again, let's try that again. This is not a perfect square trinomial. I could possibly figure out what multiplies to 5 adds up to 4, so you could probably use factoring for this. But I want you to be able to practice with completing the square just so you see that you have multiple methods to use. So let's bring c over to the other side. So that puts 5 over here. X squared plus 4x. I'm going to use my formula, b over 2 squared. So b is 4. 4 over 2 squared. 2 squared. 4. So this becomes x plus 2 squared, right? Because I'm taking it straight from here. And on this side, I'm going to add 4, which gives me a 9. Right? That's like the same thing as adding 4 over here, but all I did was factor it from here. Now I take the square root. So this becomes a positive negative 3, and on the other side, I am left with x plus 2. I'm going to subtract 2. So positive 3 minus 2 is a 1, and negative 3 minus 2 is a negative 5. So my final answer is a negative 5 and a 1. My solutions are negative 5 and 1. My zeros are negative 5 and 1. My x-intercepts are negative 5 and 1. And my roots are negative 5 and 1. I'm going to leave this on the screen. I want you to pause the video and try number 3 and 4 before you check your answers. Now that you've tried 3 and 4, or maybe you tried 3, and then you're going to try 4, go ahead and check your answers to make sure that you're completing this correctly. We're going to do some more examples because sometimes you're not going to end up with these perfect integers. Sometimes you might get irrational solutions. So what we're going to do is first solve the problem, and then we'll take our notes. We're going to follow the same steps. I'm going to bring c to the other side. So I bring 4 to the other side. X squared minus 2x. I'm going to do b squared, b over 2 squared, which is negative 2 over 2 squared. Negative 1 squared, negative 1. So I'm adding 1 to both sides. I get a 5. And on the other side, when I factor it or use this number, I get x minus 1 squared. I take the square root, and this is where I get that irrational solution. Although I get x minus 1 here, on the other side, I actually just get positive negative root 5, or positive negative square root 5, or positive negative rad 5, however you want to say it. Okay, I can't simplify it, right? There are no factors that multiply to 5 that are perfect squares. So I'm just going to add 1 to the other side, right? We're going to simplify it. So x equals 1 plus or minus root 5. That is our answer, and sometimes you cannot go any further than that. So I'm going to show you the notes that you can take. What you'll see is that you're going to solve it just as we have, but sometimes radicals can be simplified, and we will do an example like that. Go ahead and pause the video so you can take these notes. Now that you have your notes, you know what to look for. Let's try number 2. I'm going to bring c to the other side, so I get a negative 46 on here, and x squared plus 16x equals. Great. Now I'm going to do my b over 2 squared, so 16 over 2 squared, which is 8 squared, 64. So I'm adding 64 to both sides. This allows me to factor this to x plus 8 squared, right here. And then the other side, when I do the math, gives me 18. I'm going to take the square root. So I find out that the square root of 18 can be square root of 9 times 2, so square root of 9 times the square root of 2, which gives me a positive negative 3 root 2. So here we go. I simplified it. So I get x plus 8. Now I'm going to subtract 8. Now, I cannot combine this, right? This is, the 3 is being multiplied to here. So what this is going to look like is a negative 8. plus or minus 3 root 2. So negative 8 plus or minus 3 root 2. I'll leave this on the screen for you so that you can use it as a reference while you do number 3 before you check your answer. All right, let's check our answer to number 3. So you should have gotten negative 4 plus or minus 5 root 3. Go ahead and continue to practice. As you can see, there's tons of practice with when a equals 1. And the next lesson will focus on when a is greater than 1.